Okay, this is term 3, week 5. Term 3, week 5 Chem. Okay, very easy. I think from what I've seen. Let's start. Which are endothermic processes? I'm gonna solve this quickly. Endothermic meaning it takes in energy, it absorbs energy. To melt an ice cube, obviously you have to absorb energy because from melting an ice cube you're going from the solid to the liquid. And to go from solid to liquid you have to absorb energy to break down the bonds between the ice cube so that it becomes a liquid which has flowing bonds. Okay, uh, so that's why you need to absorb energy to go from solid to liquid, or in this case melting. Anytime you're going to the right, that's always endo. Okay, and if you're going from gas to liquid or liquid to solid to the left, it's always exo. Okay, المهم, first one's correct. Heating carbon with water vapor to form hydrogen gas. I explained this last week. Heating doesn't necessarily mean exo. It means endo because we're heating the carbon. The carbon is absorbing the heat energy with water vapor to form the hydrogen. So in order to form the hydrogen, it has to absorb some heat. That's absorbing energy. Okay, so that means it's endothermic. Cooling water vapor, that means going from gas to liquid, and if it's going to the left we said it's exo, so obviously wrong. Okay, reacting NaOH with HCl. Okay, this was in the book I think, but you just memorize it. It's wrong because this reaction actually releases some heat. Okay, it releases some heat. If it releases heat, not absorbs heat, if it releases heat, that means it's exo. Okay, so that way it's wrong. Okay, question 2. The change in heat is delta H. Okay, this is very easy. Question 3. Okay, Hess's law states that the heat absorbed by a reaction is independent of the path followed. Remember, if I would have Na plus Cl gets me NaCl. Okay, it's the same as saying NaCl gets me Na plus Cl. These are the same thing. If this was the heat energy of this delta H was 26, this here would be also 26, but it would be negative, right? Because we switched it. Okay, just yani, you can just take a quick example. Okay, what does it only depend on? It depends on the initial and final products. Okay, question 4. This one again, this was from last week. Okay, calculate the energy changed, right? And they gave us the bonds. Okay, whenever working with bonds, delta H equals, let's say, initial minus final, right? It was, how did I write it? I forgot. Let's just say initial. Oh no, it was sigma. Yeah. Sigma energy of the reactants minus sigma energy of the products. Okay, so add these and then subtract the initial ones, the reactants, by the products. Okay, so in this case it's gonna be let's find the reactants, the energy of the reactants. Okay, it's gonna be equal to, we have a double bond here for carbon, so that's gonna be 602. Okay, 602. Okay, plus we have 4 CH bonds. Yeah, 4 of them. So 4 times CH, which is over here 413. Okay, then I don't know how much this equals. I don't have a calculator beside. Actually no, I do. Let me do some calculator. Sorry, and I also forgot to add this CL bond, which is 327. So add 327 and you get for the reactants it's 2494. 2494. Okay, how about the energy for the products? Okay, it's gonna be, you have a CC bond, so that's gonna be 346. Okay, plus we have 4 CH bonds, one here, one here, one here, so 4 times 413 again, because CH is 413, and then CCl bonds, we have 2 of them. Okay, so 2 times plus 2 times the CCl is 327, and you're gonna get, oh, this wasn't, wait, this one here wasn't plus 327, my bad. And why did I put CL was 240? I don't know why I put. المهم, you still get 2494 as the initial. المهم, let me go back to the products. I've been getting I'm losing track. When sort of, yeah, here. So just add these up. 346 plus 4 times 413 plus 2 times 327. I'm just doing it on my calculator. I get 2652. And if you subtract 2494 minus 2652, if I'm not wrong, 2494 minus 2652, you get minus 158. So delta H is minus 158, and they want 4 SF, so you put the 0.0. That's it. Okay. Question 5. Okay, let me make this a bit thinner. Can I? Yeah, okay. Okay, this is a bit better. Okay, this is the same as last week. They'd give you 2 reactions or 3 reactions, and I didn't do the AMS last week because I had IG. But I don't know how they got it for you in the exam. So tomorrow I'll be seeing for the first time. I really don't know. And they would say find the energy of this final reaction, which is different from these 2 reactions. So the first thing I'll tell you to do always is to write down the reaction you want, NO plus half O2 to produce NO2. Okay, this is what we want, right? All of this. The second step I like to do is I like to see, I leave oxygen for the end, right? I leave oxygen to the last. Okay, I see what do I have? I have NO2 on the product side. So now we have to take a reaction that has NO2 on the product side, and it's going to be this one, NO plus O3 to produce NO2 plus O2, right? So we're going to copy down this reaction. Do we need to flip it? No, we don't, because NO2 is in the products here and NO2 is in the products here, so there's no need to flip. So we just write it as it is. And since they both have the same coefficient, also there's no need to multiply by anything. So let's write down NO plus O3. We just copy down the reaction to produce NO2 plus O2. And the delta H of it, since nothing changed, it just stays as it is, minus 122. Okay, Hala, we're getting there, right? But the part missing now is this oxygen part, right? So we have this part, the oxygen part. So we need to somehow, I told you with oxygen last week, I remember telling you guys, oxygen is a special case, okay? So since it's in the reactants here, it doesn't mean I have to put it in the reactants here. Well, it does kind of. Yeah, it does, sorry. It means I have to put it in the reactants. But you have to understand, with oxygen, it's a special case. You don't just write it as the same coefficient. No. Okay, you have to see, how can I obtain this half O2? Okay, this is what I want. This is my final reaction, right? How can I obtain this? Let's see, what do I have? I have 1 O2 over here, right? So I'm going to copy down this reaction, the one with 3 O2, right? I'm going to copy it down, but I need to make it in a way where once I subtract the O2 here by this 1, I'm going to end up with 1 over 2. So something, let's call it X, minus this 1, since there's no coefficient, I mean it's 1, minus this 1 equals 1 over 2, and you're going to get X equals 1.5, or if you want 3 over 2. Okay, 1.5 is 3 over 2. So that means I need my coefficient of O2 to be 3 over 2, right? 3 over 2. So it's going to be 3 over 2 O2. Okay, so I'm writing it now in the reactants. Why am I writing it in the reactants? Because I have my final answer. It's in the reactants. O2 is in the reactants. So I put the O2 in the reactants. So I'm flipping this reaction. So now it's 3 over 2 O2 to produce 2 over 2 O3. Why did I divide O3 by 2? Because I divided the O2 by 2. It was 3 O2. It became 3 over 2 O2. So I divided by 2, right? So since I'm dividing the O2 by 2, I have to divide the whole reaction by 2. So this O3 also I divided by 2. And instead of 2 over 2, I can just write 1, and you don't write the 1. So they cancel, 2 over 2. So O3. Okay, and what's my delta H? Since we flipped it, it's going to turn positive. Since we flipped it, right? We reversed it. It's going to become positive 47. But also we divided by 2. So that means it's going to be positive, okay, since we're dividing by 2, 223.5. If I'm not wrong, it's 213.5, sorry. 213.5. Yeah, 213.5 positive. Okay, so now we can start canceling, right? O3 can cancel with O3. 3 over 2 O2 minus 1 O2 gets me 1 over 2 O2. NO can't cancel with anything, so I just bring it down. NO2 also I can't cancel with anything, so I just bring it down. Okay, the 3 over 2 O2 minus 1 O2 gets me 1 over 2 O2. Okay, and is this the same reaction that we had at the start, or the one they wanted us to find? Yes, it is. So how do I find the delta H? All I do, I just add the ones for the reactions. Okay, minus 122 plus 213.5, and you get plus 91.5. I know it might be tricky, but it's really the only way to do it. Even in the book they say it like this. Just flip. You have to somehow NO at the start, so you put NO at the start, copy it down, and then when you have oxygen, you just have to figure out which one subtracts to get that. And then obviously the energies, if you divide by 2, you have to divide the energy by 2 and flip it, the sign of the energy, whatever. Okay, this is the question. Oh no. Calorimetry is the measure of reaction heat. Okay. أنا صراحة I was absent for this lesson. Okay, so I just went over the notes and like it all made sense. It's all in the notes. Calorimetry. Whoa, can I not write? Yeah, see, calorimetry is the measurement of the heat, and the calorimeter is the name of the device used to measure the heat of reaction. The bomb calorimeter is used to determine delta H at a constant volume. Okay, these are all questions that could come. I'm just explaining, just putting them in the video. Maybe they come. Using a calorimeter, the amount of heat is called Q. Okay, Q equals MC. Whoa, why did my brightness go down? Hold up, my brightness went down for some reason. المهم, Q equals MC delta T. Okay. What is Q? Q is the amount of energy needed to heat. Not needed to heat. Q is the amount of energy produced, heat energy produced, detected in the calorimeter, because the calorimeter is the one that measures the heat. Okay, and then the amount of heat detected is called Q. What is it equal to? It's equal to MC delta T. M is the mass of the solution. C is the specific heat capacity. Okay, how do they say it? They say it's the amount of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. How they say it? They would say that NO2 مثلا, for example, they would say NO2 needs 5 kilojoules to raise it by 1 degree Celsius. That's it. That's all they say. It would say it would need 5 kilojoules to raise the solution of 1 gram by 1 degree Celsius. So C would be 5 kilojoules. Okay, they'll always give it to you. Delta T is just the change in temperature. You just do it final temperature minus initial temperature, and that's it. They don't ask any question about this formula, but it's very, very valuable to know it, because I've seen questions about it in the course revision. Okay, it's not in the quiz. I don't know why. Maybe it doesn't come. Inshallah, it doesn't come. But just take. Okay. So like for example, this question here, 0.71 joules to raise the temperature of 1 gram of graphite by 1 degree Celsius. So here, they gave you C. C is 0.71. Okay, so they want the energy required to raise the temperature of 1 mole of graphite by 2 degrees Celsius. I'm just going to solve part A just so you know. Calculate the energy required, so we have to use Q equals MC delta T. Okay, the mass, they didn't give us the mass, they give us 1 mole of graphite, and graphite is actually carbon, which is equal to 12, I think, or I'm not sure, I'm not 100% sure. But whatever it is, you just take the molar mass of whatever they give you. They usually give you the molar mass. Okay, I think it's carbon. If not carbon, I think it's C4. Wait. Let me see what it is. Yeah, I double checked. Graphite is carbon, which is just 12. Okay, so they said 1 mole, so obviously the mass of it will be 12, because N equals M over M. 1 mole equals the mass of carbon, we don't know it, over the molar mass of carbon, 12. You get the mass is 12 grams. المهم, times C, which is 0.71, times delta T, which is 2 degrees Celsius, and you get your answer. Okay, this is just how to apply the formula. Okay, in case it comes, I hope it doesn't come. Question 7. This is the one you need. Yeah, this is the one we need the formula. Okay. Also, after the formula, I don't know where. Here's the page. After the formula, there's also enthalpy change. Okay, delta H. You can also calculate delta H if you have this Q. Okay, and delta H is actually equal to minus Q over N. Okay, whatever. Okay, blah 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 blah. Okay, delta H equals minus Q over N. That's the second formula you're gonna need, and you're gonna use it for this question. Okay, let's read it carefully. The temperature of a particular calorimeter and the water it contains, okay, to change it by 1 degree requires 5 kilojoules. Okay, so they actually gave us the Q. Okay, when they say in kilojoules, that means it's Q. Because look, wait, let me show you. It's measured in kilojoules. Q is the amount of heat energy, and heat energy over here. Heat energy is measured in kilojoules. So whenever you see kilojoules, يعني هن عم بيعطوك الQ. Okay, so they gave us Q is 5 kilojoules. The complete combustion of 7 grams of ethene gas, so they give us the mass, 7 grams, in the calorimeter causes a temperature rise of 5 degrees Celsius. Henry, they gave us the Q for 1 degree. Okay, so for 1 degree Celsius, it was 5 kilojoules. Okay, we're just gonna write this down. They gave us, the complete combustion of 7 grams causes the rise of 5 degrees Celsius. So it changed 5 degrees Celsius. How much kilojoules is that going to be? Obviously, you cross multiply, you get 25 kilojoules. So this is just to understand that my Q is 25. Okay, let me continue. They want the heat of combustion, right? The heat of combustion is delta H. And what do we say delta H is equal to? Whenever it's just like this, it's very vague. When the question doesn't give you much info, just like this, you use minus Q over N. Okay, that's the formula. What's our Q? It was minus 20. It was 25. So it's going to be minus 25 over N. And what is N? N is moles, right? And N equals M over M, which in this case is the mass, 7 grams, over the molar mass, which is given, C2H4 is 28. So it's going to be 0.25. So 25 equal to minus 25 over N, which is equal to minus 25 over 0.25, which is equal to minus 100. Okay, that's your answer, minus 100. Don't forget to make sure you get your Q. إذا مش إذا بيعطوك 5 kilojoules يعني أنا my Q is 5 kilojoules. Make sure you know how much temperature is how much is the temperature being changed. Okay. Okay, question 8. They give us carbon plus half O2 gets you CO, carbon plus O2 gets me CO2. They want the final reaction CO plus half O2 gets me CO2. How much is the delta H? How do we do it when we have like this? We just write CO, we write our final reaction down, we copy it down, and we see. First we want CO in our reactant side. In this case, we have CO in the product side, right? So what do? We flip it. So it's going to become CO to produce C plus half O2, صح? Okay, and what's the delta H for it going to be? Since we flipped it, it's going to become positive, so it's going to become 110. And we didn't divide it or multiply by anything. They're both CO عادي. Okay, so we don't multiply or divide the delta H by anything. تمام. نحن بدنا ال CO2 in the products. In this case, we have CO2 in the products, so no need to flip it. We can just write it down as it is. C plus O2 to produce CO2. Okay, with delta H تبعتها, it stays the same, which is minus 393. Okay, in this case, why it's nice? Because you don't have any reaction that has oxygen. There's no oxygen reaction. It's just the oxygen is being carried along with the other reactions. So that's why it's a bit easier, this one. Wait, let me drink water. Sorry, that's why this one's a bit easier. So now we can just cancel C with C. Okay, O2 minus half O2 gets me half O2. Okay, and you put it on the left side. You always put it on the left side if yani the one on the left is bigger. This is 1, this is 0.5. 1 minus 0.5, 0.5. It's positive, so just keep it on the left side. Okay, so we're done with the oxygens. Okay, then we're just left with the CO. We cancelled it already. We took it down, right? We're just left with CO2 here. Are these the same reaction? Yes, they are. How would I find the delta H? I would just add these up. 110 minus 393, and you get minus 283. Question 9. Okay, I think they just want, So they want smallest whole numbers, right? So what do? We have the 1 over 2. How would you get rid of it? You just multiply by the denominators, times 2. Okay, so you just multiply everything by 2. So it's going to become, instead of C, it's going to become, whoa, what happened? Instead of C, it's going to become 2C. Okay, and obviously put the state symbols, yeah? It was solid, so just put solid. And the half O2, it cancels the denominator, so it becomes O2, and it's a gas. To produce, obviously, multiply everything by 2, 2CO. Okay, gas. And since the delta H, obviously multiplied by 2, it becomes minus 220, right? Since the delta H is negative, meaning it's exothermic, okay? If it's negative, that means the reaction is exothermic. Meaning, and if I'm writing down the reaction, where am I going to put the energy? In the reactant side or the product side? I'm going to put it in the product side because it's exo, it's releasing energy, so it's part of the products. Okay, question 10. Write the reverse reaction. Very easy. Just swap it. SO2, O2S. Just swap them. SO2 goes to the front to produce S plus O2. Okay, and don't forget the state symbols. And then what happens to the delta H? If it was negative, it becomes positive. since you're flipping it, it's reversed. Question 11. Okay, very easy. They're saying write the reaction in reverse. Again, if it's A plus B to produce C, put C now produces A plus B. Just flip it. Very easy. And if the delta H was X, it's gonna become minus X. You just flip the sign, صح? Okay, can you write B plus A? I mean, you should be, but just please, if it starts with A plus B, then copy it down as A plus B. Okay, just to avoid any mistakes. Maybe they decide in the exam to not give it to you. I don't know. On which side was the energy term found in the reverse equation? If it's negative, what's gonna happen? It's gonna be exo, right? Exothermic. Okay, if it's exothermic, where do I put the energy? I'm gonna put it with the products because it's being released. Question 12. Uh, if the products have less heat content, what does it mean? Less heat content? That means it's exothermic. If the products have less energy, that means it's exothermic because energy was released to the outside, so the products have less energy. So that means energy is released during the reaction. Okay, that means delta H is negative. Okay, if it's exothermic, it's always negative delta H because to find delta H and when you have a reaction. I'm not saying when you have the bonds is different, but when you have a reaction, delta H is always products minus reactants. Okay, if the products have less heat, let's say here it was 7 and here it was 9. Sorry, is the products other way around? If the products was 7 and the reactant was 9, you're going to get negative 2. So what I'm trying to say is when the products are less than the reactants, that means you're going to get a negative answer. That means the products have less energy. That means it's exothermic. Just trying to explain why it's exothermic when it's negative. Okay, المهم, delta H is going to be negative if it's less heat in the products. The reaction is exothermic. Okay, please don't get mixed up with what I just said with the other question, the one where you had bonds. Remember, and I told you for bonds, where is it? Enthalpy change. Okay, for the bonds, you always subtract the reactants. You always subtract this over here by the products. Okay, please don't forget that. I know what I just said contradicts that completely, but what I said isn't for bonds. It's for something else. Okay, and energy is released when bonds form, and it's absorbed when bonds break, because you have to absorb energy to cut this bond and break it. That's it for this week. Thank you so much for watching. Good luck.